Hi guys, welcome to my video for how to carry out the safe isolation procedure of an electrical circuit. Within the electrical industry, we need to be able to safely isolate electrical circuits for us to carry out work safely, obviously, and not get hurt, electric shock, etc. Okay, so there's a certain procedure that we are told to follow. It's a requirement that we follow this procedure before carrying out any work on any electrical circuit. To obviously keep ourselves safe, as I said, but also to avoid damaging any equipment, any materials, anything of the customer's property. So the procedure that we need to follow is that we need to ask permission before isolating the circuit. So we ask the client, we identify the circuit, so what circuit we want to work on, lighting, sockets, etc. We then switch it off and we lock it off with a padlock. We keep the key on us at all time, or the code. We make sure it's labelled, and then we test our tester to make sure our tester's working. We test the circuit to make sure it's dead, and then we test our tester again just to make sure it's still working at the end. Okay, so the circuit I want to work on today is the lighting circuit in the shed. We're changing some light fittings in the shed for these people. I've asked if it's okay to switch off the circuit, and they said yes, no problem. So that's what I'm going to do. I'm going to identify the circuit, and luckily this circuit is labelled here. Not always the case, so sometimes we have to go find which circuit is that we want to isolate. But for this purpose, it's the shed lights. Okay, so I've asked permission, I've identified the circuit, and I've switched it off. Now I need to lock it off. I'm going to use one of these padlocks. This has a code on it. I'm the only person that knows this code. It also has a label to let everybody know that somebody's working on that circuit. So once I fit this in place with the breaker off, you won't be able to turn it back on. So that's in place now. You can't physically turn that breaker on. So that means I'm safe now, in peace of mind that nobody can turn this breaker on while I'm working on the circuit. Okay, what I need to do is make sure that the circuit is most definitely isolated and switched off. How I do that is with a tester, a voltage tester. All testing equipment needs to conform to GS38 document, and a proving unit. What this proving unit does is checks that my tester is working. So all lights up, that means we're good to go. So I'm going to check across my circuit, which luckily I have a switch here for the lighting circuit, so I can check if there's power here. If there's no power here, it means the rest of the circuit's okay. So I'm going to check across live neutral, live earth, and neutral earth. And that's all okay. That means that there's no power here. That's switched off. What I need to do now, the final step, is to check that my tester is still working. I've not damaged it during the testing procedure, because potentially what might happen is it's actually still live. The tester's gone faulty in between me testing it, and that is still live. So what I need to do is make sure that this is still working, and it is. So there we go. I'm happy now that that circuit's isolated. Nobody can turn the breaker on, and I'm okay to go to work and carry on with the job. Okay.